everybody. So now that we've covered kinematics, which is the study of motion, it's time to discuss what causes the motion, which is force. Isaac Newton came up with 3 laws to summarize dynamics, which is the study of motion and forces. And I'm going to paraphrase in my own words. So you can look up the technical definition, kind of textbook definition, but paraphrasing, the first law is if you have some object traveling at some velocity, like some object at some velocity, it's going to continue moving with that velocity. I'll just write first law. It'll continue going at this velocity forever unless this object is acted upon by some force. So if it's at rest, it's going to stay sitting there at rest forever. Right? If it's moving 1,000 meters per second in space, it's going to keep going forever unless some force acts on it. So that's the first law. The second law sort of quantifies that relationship. And it's basically if you have a bunch of forces acting on some object like this, like a bunch of forces, like a bunch of them. If you take the resultant of all of those forces, right? So you take the vector sum of all the forces acting on the object, it's proportional to the acceleration. And that constant of proportionality is mass. Okay, and this is acceleration. All right, so sum all the forces is mass times acceleration. So these forces are vectors, and the unit is, we named it after Newton. So Newton. The unit for mass is kilogram, and then acceleration is meters per second squared. So technically, right, a Newton is a kilogram meter per second squared, but we named it after him. Right, so, okay, so that means this thing is some mass. Okay, then the third law is forces. Let's say if you, like you push this crate, right? Like you're pushing a crate toward the right with 10 newtons of force. Then the crate is pushing back against you also with 10 newtons of force, but in the opposite direction. So it's like equal and opposite reaction, action-reaction pair. So action. Okay, so that's Newton's third law. Okay, and then examples of forces we'll consider in this class. If you have like a rope or a cable or a string, then there's going to be a tension. So this is a tension force. And for now, we're going to assume that tension is constant along the entire rope. We'll modify that a little bit later in the semester. Like if you have a pulley over here, and let's say you're like pulling like you're pulling this crate up in the air, then the tension here is the same as the tension here. For now. That'll change later. Okay, and then another type of force, let's say there's a ramp. There's a ramp. And you put a block sitting on the ramp and it just sits there. It's not moving. It's static. So there's going to be some contact force, right? Because the block is in contact with the ramp. So we say there's a contact force between the block and the ramp. Contact force. But we can decompose the contact force into components. One part parallel to the surface. So for example, this way, parallel to the surface, and one part normal to the surface. So the part parallel to the surface is called friction. And the part normal to the surface, we just call, for lack of creativity, normal force. And so normal means perpendicular, right? So just less syllables. All right, so we'll discuss this in further detail later as well. And one more type of force is weight. So in this context, weight is just going to be like you have some object with a mass. Let's say it's like 2 kilograms. Then if it's subject to gravitational acceleration, then the weight is just that mass times g. So weight is a force, right, in newtons. Mass in kilograms, and g, you know, is 9.81 meters per second squared. Okay, and then last note, if you hear pounds, like you go to the doctor's office and you step on the scale and then you get weighed in kilograms, or at home you have a scale, it's in pounds, but kilograms and pounds aren't actually the same unit. Kilogram is a mass, pound is a weight. It's a force. The mass is called slug. And then g would be 32.2 feet per second squared. Okay, so, right, pound is a force. Kilogram is a mass. So they're different. Don't mix those up. And then the mass unit for the kind of imperial system is the slug. I'm not sure if that's common knowledge. Okay, let me know if you have questions. I'll see you in the next video.